Hola clase. Today we are going to learn to solve problems that have bearings involved in them. We're going to do it with a specific example because it's going to make much more sense, but I will give you a how-to guide to tackle this. Now remember that bearings are simply angles but have a direction. They are measured from the north and they always have 3 digits no matter the value of the angle itself. So they go from 0, 0, 0 to 360. To tackle all of these things, you need to know pretty much every single angle property and skill in the unit. That's what makes them tricky. You need all the properties of angles, and by that I mean angles at a point, in a line, parallel lines, all of the ones that you use in little parts. Then you need to know your Pythagoras theorem, and you need to be able to work with trigonometry. That's what makes them tricky. You need everything. Now for the how-to, first you always need to identify what they ask of you. What do you need? Especially you need to figure out if what you need is an angle or a length, because that's going to make things slightly different. Then from your diagram, you want to label everything in your diagram. And most of the times they will give you a diagram, but if not, you start from 0 and draw yourself one. And then you want to begin breaking the angles and forming right angle triangles. And for that, that's when all the properties come in handy, all of them together. Now we're going to try to do it in an example, and probably we're not going to be able to fit it all in one screen, but we will try. Now, if we try to look at this example that I'm just putting the words here again, this is from a past exam. And when you tackle these things, you begin working backwards from what you want to what you need. So basically, you're going to identify here what do you need. And you're going to ask yourself, well, do I have all the pieces that I need? And well, in an ideal case, that could be a yes. And you would just combine the pieces and get what you want. Most of the times it's going to be a no, I don't have the pieces. Then you're going to repeat the process again. Okay, what do I need to get that piece that I'm missing? And you're going to repeat the process. Are all the pieces there? And from there, yes, it could be that you got them or no, and then you repeat that process. It would get to a point that you actually have all the pieces, so you can work backwards to get whatever it is that you need. Now in this case, they give us a story about a ship that is sailing throughout New Zealand, and it's actually a famous ship, sailed along the coastline, and they give me some things in the text and some things in the graph. This is what the graph gives me. They are telling me that the ship sailed from G to S with a bearing of 054. So I'm going to mark it here. I want to label everything. So this could be a 0, excuse me. 054, and then it changed direction and it had a bearing of 294 for 635 kilometers more. So this bearing here, 294, of course, degrees, and what they want is this bearing here from G all the way to M. Okay, now it's going to come handy have this slightly bigger, so we've got a bit of space, and that should be enough. And I'm going to start thinking of a strategy in the diagram itself. So this whole bearing here, it's going to be 270 degrees plus some extra. If I had that extra, I could have the whole bearing here. So then I'm going to begin thinking, how do I get that value there? Now, important thing, I know that all of these lines are parallel to each other because they all facing north. So I can encase this whole thing in a bunch of, let's see, without eating it here, a bunch of right angle triangles. And from this triangle where alpha is, if I know, let's call these X and Y, if I had those two, I could get the alpha that I'm needing, and then I could get the bearing. So then I'm thinking, well, how do I get these two? I don't have anything in this triangle. Let's use colors. This triangle here does not give me anything that I can use. So I go backwards and I go, well, this, it's actually this section there plus that section there. So I'm going to call them A and B, and if I would new A and B, I could get the X. Same with this Y, that Y here, if I call this one, I don't know, if we call A, B, C, and D, this Y here is the whole C minus D. So again, I'm in this position here. I'm halfway through. I need those pieces so I can work backwards. All right, the next step is thinking, well, how do I get those A, B, C's, and so on? So I'm going to start with what I know. If I go, let's try another color, this triangle here, let's make it red so it's easy to see. And then I begin thinking, what do I know? Well, I know one of the lengths, which is a good thing. I'm making it a right angle triangle, so I know I will be able to use trigonometry. And then I begin thinking, what do I know? Well, I can get this angle here, because I know that angles at a point, this point here, are going to add to 360. So I can think, well, this is 360 minus 294, which is going to be, let's do it in here, 66 degrees. Well, if I know that, I'm going to be able to get the A and get the C, which is a good thing. Now, of course, I can get other angles as well. If I've got this 54, I can get this one here, because remember, I'm making this a right angle. So I can come here and go, okay, 90 minus 54, and that could give me a 36. And remember, all of this is thinking of the pieces I need to get that A and that B and that C and that D, to go backwards to get the X and Y, to go backwards to get the bearing. Now, once I've got all of those angles, and there will be some of them that we don't even know or don't even need. But with all of that, I would be able to get the B and to get the D. So now my thinking process is complete. I've got my strategy. So if I'm thinking before I write anything, this is the process that I did. First, I want the bearing. Well, I don't have it, but I know that the bearing would be 270 degrees plus the alpha that I drew in there. Well, if I had alpha, that could not be a problem, but I need the alpha. Well, for that, I need X and Y, so I can link them using trigonometry, because I'm thinking, oh, okay, that could be two sides of a right angle triangle, so I could get an angle there. Well, I don't have them, so I break them into pieces. So I go, okay, for X, I need A and B. For Y, I need C and D. And I don't have any of those. So then again, I go back and think, how can I get them? So I make the right angle triangles, and I figure out that there is a way of getting these two because they are in a triangle, which is this one here. I've got one length, and I figure out I need an angle. Okay, once I found the angle, yes, I could have all the pieces to go back there. I repeat the process with B and D, which are in, let's make it somewhere in here, this other triangle here, from which I realize I've got a length, but I need an angle, some angle, and I figure out, okay, well, I can use this one, that's fine. And I've got all the pieces. Once I've got all the pieces, it could be great because it could allow me to get A, B, C, and D, which would allow me to get X and Y, which would allow me to get the alpha, which eventually would allow me to get the bearing. All right, this is our thinking. Now, this is definitely not going to fit in one screen, so we may have to break the video in two if it goes longer than 10 minutes. Right, now I'm ready to actually start writing all of that. So we're going to come here, and remember, everything needs to be on the paper. So, okay, that bearing, it's 270 plus alpha, and alpha, it's going to be the inverse of the tangent of X over Y. So I need to begin thinking about getting X and getting Y. Now for X, I'm going to justify everything. Angles at a point, add to 360. That allows me to call this angle here beta. So I go, okay, then beta is 360 minus 294, which is 66. That gives me a couple of things. With that, I can get, let's scroll down, let's go here. With that, I can get A. I name it in the diagram so everybody knows what we're talking about. And that's going to be, let's make it here so you can see it. That's going to be from this angle, this 635 and this A. This is actually the adjacent, so it's matching, and this is the hypotenuse. So the link would be the cosine. So 635 times the cosine of 66. And if you need to think of that, I'm going to put it here so you can see it. Comes from rearranging. Cosine of 66 equals adjacent over hypotenuse, which is 635. So I'm just putting things already there. It's for space. If you do that, I tell you what it gives you. It gives you 258.27. Now I'm going to get C at the same time because it would be the opposite side. So now it's going to be 635 times the sine of 66. And if you do that, it gives you 580.10. Mental check. None of these two numbers is bigger than the hypotenuse itself. So I know I didn't do anything weird there. Now I'm going to deal with the other triangle, and now that I'm seeing it, I can come here and use this angle there. I'm going to call it alpha beta gamma, because I can come from, let's make it in here so you can see it, from this set of parallel lines that are being linked by this distance and use angle properties. I could have here a set of alternate angles. So I can go alternate angles in parallel lines are equal. Remember, I don't have to write the whole sentence, but it's good to actually have something there. So therefore, using that, gamma is going to be 54 degrees. With that, I can get B, because it will be, let's move things so things are like actually a bit tidy. So from this triangle, so you can see it, if this is gamma and I want B, which is this one here, and I've got the hypotenuse, this is going to be the adjacent, this will be the opposite. So it's more of the same. The link between adjacent and hypotenuse is the cosine. So that means that B is going to be 448 times the cosine of 54. If you do that, that is 263.22. And I can get D. So I'm getting all the pieces at once. And that's going to be the opposite. So that is going to involve the sine. If you do that, gives you 362.43. Well, with all of that, I'm going to come here, and let's see if I do it without having to scroll again. But then I can get X, which is A plus B, and I can get Y, which is C minus D. X gives me 521.59 kilometers, but I'm only going to put units at the end. And this would give me 217.67. With all of these two, I can get alpha, because I say that would be the tangent inverse, because again, in this triangle here, this alpha, it's linked between the adjacent and the opposite. The one that links all these two is the tangent. So tangent inverse of X over Y. If I do that, that gives me 67.32 degrees. And I already said that the bearing was 270, excuse me, plus the alpha. So that I just need to add 337.34 degrees. Now I've got what they asked me, so I box it, and I'm done. Okay, that took definitely far more than a screen, but this is how you tackle one exercise with bearings. Now we made one, so now it's your turn to go out there and practice. Thanks for watching.